So lesson 4.8 is going to move us into another way to solve quadratic equations. There are often many ways to do the same thing. And so in this lesson, we're going to learn about the quadratic formula, which I have written over here on the side. Make sure you write this down in your notes. This is the formula to solve for x using a quadratic equation. So this only works for quadratics. You can see there are the variables a, b, and c in that formula, and they correspond to a, b, and c in the quadratic equation according to it being written in standard form. So in number one, your a value, just write this down over here. B equals -3 and C equals 5. Okay, so we're just going down the line of standard form in that quadratic equation. So I'm going to take those three numbers and fill them in for that quadratic formula. Now, if I wanted to find the exact values for x, like they ask in starting with number 13 on the worksheet, I would fill in all of those letters and calculate out x. I would get my solutions. I'm really going to be getting the actual x values where this quadratic would cross the x-axis. But we can use what's called the discriminant, which I've written over here in blue, which is just b squared minus 4ac. It's just the part under the radical. And we can use that to at least figure out how many solutions there will be and whether they're real or imaginary. Okay, so we're going to practice with that a little bit. It's not going to give us the exact solutions, but it'll give us some information. So for number one, b squared minus 4ac is going to be -3 squared. Make sure you raise the negative sign with it when you put the square in. It needs to be in parentheses. This will be 9 minus 20, which is going to give us -11. So now if you look over here at my rules, if b squared minus 4ac, which in this case for number one is -11, if it is not greater than 0, okay, so we come down to the second option. These are three options. It's not equal to 0, but it follows this third option down here, which is less than 0. So because -11 is less than 0, then number one will have two imaginary solutions. All right, so number one, two imaginary solutions. And you can see a picture of what a graph would potentially look like that has imaginary solutions on page 294. They show you it's not going to hit the x-axis. It's going to be above the x-axis. It won't have any x-intercepts. And so you can at least get a visual of that. Make sure you check out that page. All right, so we can do the same thing with number two. Our A is 2, B is 1, and C is 2. All right, so we'll go through the discriminant and plug those numbers in. We have 1 squared minus 4 times 2 times 2. All right, that's going to give you 1 minus 16, which is -15. So here again, we've got a situation where b squared minus 4ac, the discriminant for this particular problem, is less than 0. So once again, we're going to have two imaginary solutions. So it's not giving us the actual solutions, but it's telling us a little bit of information about them. All right, so we can do the same thing on number 7. I'm realizing that that the directions on 1 and 2 didn't actually ask us to decide whether they were imaginary or real solutions. They just wanted us to find the discriminant. So in 7 and 8, they're actually asking us to find the discriminant and then determine whether there are one real or two imaginary. So we just did a little bit more work on the top than was necessary. In this problem, number 7, 4 is your b value. A is 1 and C is 3. So we end up with 16 minus 12. So in this case, we get 4. So because the discriminant comes out to be 4, which is greater than 0, that matches up with number 1 over here, then we know that this if we were to graph this, we would see that it has two real solutions. Okay, and that's going to look like a graph. Again, you can see it on page 294, but it's going to cross the x-axis in two spots. All right, we'll do the same thing in number 8. B squared minus 4ac. B in this case is -2, so make sure you put the -2 in parentheses. All right, and then from there I get 4 minus 16. So here I end up with a -12, which matches up with our scenario in number 3. Our discriminant is less than 0, so number 8 would have two imaginary solutions. All right, moving down the page to 13. Actually, let me keep it right there so we can see that quadratic formula up there. Now they actually want us to solve the equation for the solutions. So in order to do that, you have to use the full formula. You can't just use the discriminant. And so on number 13, we will just start filling in. We know that, let me write our variables up here. So our A here is 1, our B is 4, and our C is -2. All right, so a lot of times it helps, especially when you're doing the full formula, to have those 3 variables identified and above the formula so that you don't make a mistake just, transferring the wrong number over, forgetting a sign or something like that. So I like to put them above like that. So we're going to have the opposite of 4, plus or minus 4 squared, minus 4 times our A, which is 1, and our C, which is -2. So all that's under the radical, so that's the discriminant. And then 2 times A on the bottom, which is 2 times 1. All right, and then we just have to go through and follow our order of operations. So we're going to take care of that exponent under the radical, and then I'm going to do all that multiplication, and I will get a +8 when I do that for -4 times 1 times -2. So that's all under the radical, and that's over 2. Okay, and then actually add those 2 under the radical together, we'll get 24. Okay, now at this point, I'm going to need to prime factor that 24. It's not prime, and so I need to do the factor tree to make sure that I have all of my squared values pulled out. So the prime factorization, which I'm not showing you the factor tree, but I'm just writing that out there, looks like that. So that means that we can pull out this grouping of 2. All right, I'm just going to move over here. All right, so when I do that, I'm pulling that out. That's coming out of the radical. I'm going to sit it right next to the radical and then re-multiply the 2 and the 3 together that are staying in the radical, all over 2. All right, now at this point, you can see that we have the possibility of factoring out a 2 at the top there. Okay, so if I factor out a 2 out of the numerator, I'm going to end up with a -2 plus or minus. I'm factoring that 2 away from the radical, so now I'm just going to have the square root of 6. And all of that is over 2. And so now I can cancel this 2 with this 2, because this 2 up here is multiplied by what's in the parentheses there. So the final answer then is that x equals -2 plus or minus the square root of 6. Again, keep in mind that's 2 separate answers. Okay, we've got -2 plus the square root of 6 and -2 minus the square root of 6. So this has 2 solutions. So that means that the discriminant, if we go back up here to the discriminant, you can see the discriminant right here was 24. 24 is greater than 0. So that lines up with that first option at the top up here, which states that we should end up with 2 real solutions. And we can see that that did happen. We did end up with 2 real solutions. So if the discriminant and your final answer don't end up matching up, then you know that you did something incorrect with your arithmetic in the steps somewhere, in the quadratic formula. So we'll do the same thing again for 14. Identify A, B, and C. Write out the formula for the quadratic. And fill in. So here we've got the opposite of -5, so pay special attention when you end up that situation that you don't lose a negative sign. -5 goes in parentheses because we're squaring the entire value of b. Okay, and we go through and change any signs that need to be changed. This will become a +5. I'm going to take care of this square, and then I'll multiply -4, 2, and -2 together and get a +16. So right here you can see that we should expect two real solutions because 25 plus 16 is greater than 0. Okay, so we get to here. 41 is prime. So because of that, we can't do anything to factor it any further. It is in simplified form. But we can go ahead and show the two separate solutions in a little bit of a simpler form. So the way we would do that is just go through and do the division with that 4. And we can't, there's not any real, quote unquote division we can actually do, but we can show that denominator with each of those terms in the numerator. And so we would have 5/4 plus the square root of 41 over 4, and then 5/4 minus the square root of 41 over 4. So you can see again that our discriminant does match with what we actually got. We have two real solutions. These are really going to be intercepts on the x-axis. All right, on 21 and 22, they want us to first solve the equation using the quadratic formula, and then they want us to go back and solve the equation by factoring. Both of those are valid ways of solving quadratics. Okay, remember we're giving you another way with a quadratic formula. We're giving you another way to solve these. All right, so we're going to try on 21 doing it both ways. So we'll start with identifying A, B, and C. All right, and we want the opposite of B, plus or minus b squared minus 4ac all over 2 times a. All right, opposite of -2 is going to give us a +2. All right, b squared, b is -2. I'm going to square the whole thing, negative signs included, so that'll give me 4. All right, minus 4 times a, which is 1. I'm going to go ahead and write out that -24 for c because I need to remember that that's negative, and it's going to take me a minute to calculate that. All right, and then 2 times a, which is 1. Okay, so I just kind of skipped a few steps of not plugging in every number for evaluating. If you find that you're making careless errors when you do this quadratic formula, then you want to make sure you go through and, just like we did in the previous problems, plug everything in and be extra careful about your negative signs. Don't try to do any of it in your head if you find that you're making careless errors. Even at that, I don't do everything in my head. I would write down a lot of things that I feel like maybe I would make a careless error on, like this right here. Okay, so I want to remember that that was a negative sign, so those two together are going to give me a positive number, and that will be a 96 there. So now I have a nice perfect square under that radical, so that's nice to have. And so the last step here then would be taking that square root, which is 10, and putting it over 2. And you can see here we're actually going to get whole numbers. We're not going to have any radicals left. So this is a good example of where I can show you how to find both of those roots. So we have, coming over here, we've got 2 plus 10 over 2 is one of our roots, and then 2 minus 10 over 2. So if I calculate this one, I end up with 12 over 2, which is x of 6. And this one will be 2 minus 10, which is negative 8, divided by 2, which is negative 4. So our two values for x in this problem are 6 and negative 4. Now, we're going to do the same, use the same problem, but we're going to factor. So if you go and look at 21, we have an a of 1, which is nice. So we're looking for factors of negative 24 that will add to 2. All right, so we're going to start here with 6 and negative 4 because that's what we got. We're really just double checking to make sure that we use the quadratic formula correctly. So we can see that 6 and negative 4, they will multiply to negative 24. They will add to our b value of negative 2 over here. And so when I factor this, then using those two, I'm going to get x plus 6 times x minus 4 equals 0. And then I'm going to take both those binomials, set them equal to 0. X plus 6 equals 0 is going to give me an x of negative 6. And then x minus 4 equals 0 will end up giving me an x of 4. So it does check out with what we got. Actually, no, it doesn't, because I'm looking over here at my signs. Did I fill it in wrong? I want this, the signs over here are wrong. It does multiply to negative 24, but it does not add to 24. I needed the negative sign to be on that 6. So coming over here then, let me just cross through that. It would be x minus 6 times x plus 4. All right, and then that works out with x of positive 6 and negative 4. All right, so there it is, read down there. And we can see that it does match with what we got over here using the quadratic. All right, let's do those steps one more time with number 22. So my a is 1, b of negative 2, and c of 1. All right, so opposite of b is negative 2 again, so I'm going to have a positive 2 plus or minus negative 2 squared. I want to raise that whole thing, negatives included. And then I have minus 4 times a, which is 1, times c, which is 1. Obviously, I don't need to write all that down. That is just going to end up being 4. And then all that over 2. Now, right here, we get a discriminant of 0. All right, and that matched that second solution. This is the first time we've seen this. It matched that second option where the discriminant equals 0. So if the discriminant equals 0, we know we're only expecting one real solution. And the square root of 0 is 0, so don't make that more challenging than it is. So we would end up with this, just to write that out so you can see it. 2 plus 0 gives you 2 over 2, which will give you 1, but 2 minus 0 also gives you 2. You divide that by 2 and you get 1 again. So we do end up with just one solution for this equation. If we go back over to 22 and look at it, you can see, as far as from a factoring standpoint, you can see that this is a perfect square trinomial. So we have 1 is a perfect square, x squared is a perfect square. So this is where we've got our a equals x, our c equals 1, and then, I'm sorry, not our c, our b, if we're talking about a perfect square trinomial. And so when we write that formula out for a perfect square trinomial, we look at this sign right here. We see that it's a difference, and that what it says is that if you have a perfect square trinomial with a subtraction sign in there, it takes this form right here. So we fill in our x minus our 1, square the whole binomial. That's set it equal to 0. And when we do that, then we can solve for this. All right, I'm gonna come over here and finish this problem off just so I have some more room. We could do this a couple of ways, but going with what we just learned about square roots, remember we could take the square root of both sides of this. All right, and this would really be plus minus the square root of 0. The square root sign and the radical will cancel each other out, so we end up with x minus 1 here, and we end up with plus or minus the square root of 0. All right, so plus or minus the square root of 0. Obviously, that is just 0, but if we finish this off, we can take the 1 over to both sides, and we can see that x equals 1 plus 0 or 1 minus 0, but in any case, either case, it's just going to give you an x of 1. So you could do it that way. That's the way we learned to do it in this chapter. The other option, which would make more sense to you before we learned how to solve quadratics with a radical, would be to write that binomial out twice. This is how we would have done it beforehand, before we learned about square roots, is writing that out twice, setting both of them equal to 0, and when you solve, you're going to get the same root, obviously, of x of 1. Okay, so again, two ways to do the same thing, and you find that frequently throughout algebra. So just hopefully you make that connection that we're just showing you another way to do these problems.